Hello! This week at DB Boards, we're doing a featured video on how we test and build products in our tiny startup shop. Everything that we build goes through a rigorous design process, from Gerber files to prototyping. Today, we'll show you how we build the test rigs and the final products for your alarm clock kit. Much of my personal experience comes from my extremely fortunate stay at SparkFun Electronics, where I learned and developed the skills and strategies that we use for design and production at DB Boards LLC. We owe the strengths of this product line to the teachings and mentorship of such SparkFun greats as Sam Weiser, Marshall Taylor, Ted Metzroth, and Chris Francis. The open source coding style and format is inspired by the incredibly dense foundation of Arduino examples developed by Mike Grusin, Nathan Seidel, Nick Poole, Spooky, Sean Himmel, and many others. As you can see, for our programming and testing jig, we use 3 of the DB LCD RTC Uno boards as our mounting platform. Using spring-loaded pogo pins allows us to easily test blank boards. We solder in the pins to the bottom 2 boards, then drill the holes out of the third, so the pogo pins spring freely in the headers. We leave the unused headers to solder structural anchors. In order to test the boards going to the kit, we need the pogo pins to connect to the LCD and to the button board. So we flip the jig over and mount 2 tested boards to the bottom. Once the 2 boards are mounted, ProtoSnap boards are used to break out the ISP header for burning the Arduino bootloader, and the FTDI header for programming the board with the alarm clock firmware. Now we are ready to test the first board of the batch. Scrap PCBs are used to frame and support the alarm clock board. For a single board, we simply tape a temporary frame to the table. Next, solder paste is evenly applied across a palette knife before it is applied to the PCB. Using the panel stencil, it can be scraped across the top, leaving just the desired amount of paste on each of the copper pads used for mounting components onto the board. Our robotic teammate, UBART, is learning to handle panelized pick-and-place, but for our first board, we simply hand-place the components with tweezers. Once every component has been mounted on the board, it is taken outside to our extremely high-tech reflow oven. Well, actually it's a very low-cost convection oven. Using a major overkill of a power source, this baby circulates enough heat to broil to turn all paste into solder in 3 to 5 minutes, without ever getting close to hot enough to damage any of our components. This makes it a perfect setup for our open source startup. Once the solder has set and cooled, we bring the board back inside to be tested and programmed. Small clamps are used to ensure the electrical connection of all pins are ideal. Then the SparkFun Tiny AVR programmer is used to burn the Arduino Uno bootloader to the onboard Atmega. The firmware is uploaded using the FTDI. Each board can then be adjusted to correct brightness, and the button and LCD header tested, along with uploaded firmware. Once the board is approved by quality control, it is sent to kitting. For now, the custom alarm clock cutout sticker is carefully created using a standard office printer and some Scotch tape. All of the components and boards are bagged, including an electrostatic discharge bag for the newly tested Uno footprint. The sticker and all the components are carefully placed and protected in our DB Boards kit box. The boxes won't be sealed until we can put your packing slip inside, with all the parts you need to solder your very own customizable alarm clock. If you're interested in learning more about this particular product, there are links to related showcases and tutorials below. For other inspirational project showcases and tutorials, and a growing line of plug-and-play Arduino, see our store at dbboards.com. And until next week, happy hacking.